Alright guys, so again, please watch this whole video, practice your calculator skills along with me. The good thing about making a video is that at any point, if you forgot something or if you didn't hear me right, you can pause it, you can rewind it. So please do so. And here we go. So yesterday we did some basic vocabulary, and we learned about what's called exponential functions. So an exponential function is in the form of, and I kind of gave you a big old hint over there, y equals, and then we have an a number, and then a lot of times it'll have it in parentheses like this, but remember, it just means multiplication of some sort. So you could also have it like this, so you have some options of how it could look. Big thing here is that the exponent is the x variable, so that's what's making it exponential. It's kind of in the name. So just to remind you guys real quick about the different things we talked about yesterday, A was our initial or starting value, and we'll get into that in a bit, and then B was, depending on if it was growing or decaying, what we called our growth or decay factor. Okay, so that's what we did yesterday. Here's what we're going to get into more today, is especially with that B, and then how we do this in real settings. So B, here's how we decide if it's growth or decay. If it's greater than 1, that means that it's growth. And if you remember yesterday, that means the graph, if I was to sketch a little graph here, is going up like that. And then if B is less than 1, it is a decay function, so it's going smaller. So if I was to sketch it, it starts big, gets smaller. Okay, so let's practice with some actual numbers. Okay, so number 1, y equals 1/3 and then parentheses 4 to the power of x. So just think, let's identify the pieces. The initial value is that 1/3. The growth or decay factor, the b value, is the 4. So is it growth or decay? Well, look at this number right here, the b value, and then we said it's either greater than 1 or it's less than 1. So this is greater than 1, so this would be growth. Okay, asymptote. This is where it's kind of hard to see it unless you look at the graph. So I'm going to take my calculator and I'm going to plug in our equation. Remember, alpha y equals, get you the 1/3, parentheses 4, parentheses close, exponent of x. This would be a great time to pause the video. Make sure, does your screen match my screen? Okay, and then I'm going to graph it, maybe. So remember, asymptote was just the fancy word for where is our boundary line? Where is the graph not crossing? Almost always, for what we're going to be doing today, it's going to be at y equals 0, the x-axis. And that is the case here. If you look at this, it's kind of approaching the x-axis but never crossing over it. So remember, it's always y equals, and in this case, it's getting closer and closer to where y is 0. And then y-intercept, that's almost impossible to figure out from looking at the graph. So I'm going to go to my table, and we talked about yesterday how it's where x is 0. So in this case, it is 0, 1/3. Now you should notice something. Hey look, a was 1/3. Those are going to be the same every time because you're starting at your initial 0x, and that's going to be the amount there. Okay, this would be a great time. Pause it, try the second row, come back, see if you match mine. Okay, so initial value is that number in front, 5. Growth or decay factor is the number in front of the parentheses, 0.5. Since 0.5 is actually less than 1, that is a decay. Again, if you're not sure about the asymptote, we can come here and graph it. So I'm going to clear that out. 5.5 exponent of x. Graph it. Again, if it's looking like it's approaching the x-axis like this one is again, all right, it's not crossing down into the bottom part of the graph, then it's going to be that same thing. Eventually we'll look at some examples where it's been moved around, but that's going to be pretty much everything for now. Okay, y-intercept, go to your table and look for where x is 0. But once again, if you're paying attention, that is the a value. So I could have just looked over here and I would have got the same thing. Okay, so that's just kind of picking apart an equation they already gave us. What we're going to have to do actually most of the time is make our own equation. So let's just try, if they gave us what's called a rate, how do we make that magical b value? Okay, so I gave you guys this formula yesterday and I just said, just memorize it. we're going to actually use it today. One thing that we have to worry about is that R is almost always given as a percent, 15%, 4%, 12%. But we don't like using percents in equations, so we're going to use the percent as a decimal. So just as an example, let's use that first one. Let's say it's 15%. If it's been a while and you don't remember the rules, one really easy way to do this, if I go back to my normal screen, percents are just out of 100. So you could always come here if you forget and do 15 out of or divided by 100. Ta-da! But what's really happening, if you want to just do the little decimal move, is that the decimal with 15 was after the 5, and all it's doing is moving it back 2 to be before the 1. So you can just always take that decimal, move it back 2 spaces, and now you've got the percent as a decimal. So here it says if the rate is, here's the important thing, increasing by 15%. You need both of those pieces to use this equation. You always have the 1, so far we have b equals 1, but then you have to decide, are you adding or subtracting? If it's increasing, growing, anything that means it's going bigger, you're going to add, so 1 plus, and then 15% we said earlier was 0.15 as a decimal, so 0.15. So in this case, the number that would be in our parentheses, our b value would be 1.15. Okay. Next one says decreasing. So that means we're going to subtract by 4%. So again, picture taking that 4%, moving the decimal back twice. If you're not sure, try it down here. So the decimal's right here right now. We're going to move it back 1, 2. So you actually have to fill in another 0. Okay, so our b value in this case is going to be b equals 1. Again, it's decreasing, so minus, and then 0.04. Another little trick again is you can always just do whatever the number is divided by 100, and it'll do it for you. Okay, so now be careful with this. Make sure we're doing our math here correctly. It's 1 minus 0.04. So it's actually 0.96. Okay, and I want to point out what we are doing is having to make the number that they gave us ourselves. So we talked about earlier, if b is greater than 1, like in part A, that means it's growing. That matches up. If b was less than 1, like 0.96, that means it's decay, which is why we were decreasing. So this is still matching up with this idea. It's just we're having to find the b value ourselves. Okay, again, this would be a great time to pause, try this one, come back, see how you did. Decreasing 12%, so it's 1 minus, and then move that decimal 0.12. Go plug that in if you're not sure. 0.88. Again, it's less than 1 because we were decaying, we were getting smaller. Okay, so that's probably the trickiest part about this. Put it all together. We're just going to do the same thing, but with some word problems. Very, very simple word problems. Okay, so again, the things you're having to identify are initial value and then the growth decay factor, which most of the time means they're going to give you this rate. Okay, so reading through this. A car was purchased for $46,000. That is the initial price. So that's going to be our A in our equation. So without really doing anything else, on this one it says write an equation. I already know that y equals, and I'm going to put that 46,000 as my first number. And I know that I'm going to have x as my exponent. Already halfway done. And then, keep reading, the value of the car decreases. So I know it's decay. I'm going to subtract annually by 8%. So again, that's giving you R. So you have to go off to the side for a second and find what's going to go in the parentheses. So it's 1, we're decreasing, so minus, it's 8%, so move that decimal back twice, 0.08. So our B value, 0.92. Okay, so again, you're always looking for an initial value to put in the front, and then they'll usually tell you if you're increasing or decreasing, so you know to add or subtract, and they'll give you the rate, so you're going to use this to find that middle number pretty much every time. Okay, so now we have an equation to work with. We can go plug it into y equals, let's do that. So 46,000 parentheses, it was 0.92, close parentheses, make an exponent. Remember, oh, if I haven't said this, remember your exponent button is just this one right below the clear. Okay, you can make any exponent. So you don't have to click on the square because we don't want an exponent of 2. We want just whatever exponent we want. It'll make like an empty exponent and you can type in the x. So sorry if I didn't say that already. Okay, so we've got our equation. Now what part B is saying is use the equation, so we're going to use the calculator, to predict the value of the car in 2016. Now here's what's really weird about this one. We haven't really talked about this, but if you look back at the problem, it says the car was purchased in 2012. So that means that 4 years have gone by. And if you think back to like the beginning of the school year, we talked about how x a lot of times is time. So what they're basically telling us right here is we want to look at when x is 4. So you got some options. If you like using the calculator, you can just plug this in like I did, and then we can go look at the table, and we're looking at, so after 1 year, so here's the initial price. After 1 year, the price of the car would go down to $42,320. We want after 4 years, so the price of the car has gone down to $32,954. So 2 options. You can go look at your table. A second option, if you don't want to have to use a graphing calculator, as long as you have a calculator like your phone or something, you could just use the equation we created, 46,000 parentheses 0.92. And then when you make your exponent, instead of putting the x there, we're saying that x is 4 for now, so you can put the 4 in and get the same value. It's actually even a little bit more specific than the table was. So I don't mind either way. I'm going to use a slightly more specific answer, so $32,942.08. Again, I don't really care either way. So second option, plug 4 in to x. Okay, either way you do it, you get $32,954, and then I said 8 cents. Again, I'm not super picky, so if you did the table version and you got that answer, wonderful. All right. Again, great time to pause the video, try this one on your own, see how you do. So this one's going to have us make an exponential function, so we're going to write an equation, and then we're going to predict 2 things. Okay, so reading through this, let's identify our pieces. A fisheries manager determines that there's an approximately 3,000 bass in a lake. So that's kind of our starting number, that's our A. The population is growing, so we're going to add our rate of 2%, which, remember, just move that decimal back 2 places. Okay, so put it all together. The equation is going to be initial value of 3,000. Now, for our B value, we're doing 1, it's growing, and then our rate's 2%, so 1.02 is our B value. Exponent of x. Okay, so there's our equation. Now it says approximately how many bass will live in the lake after 4 years. So think about it. Remember we talked about x is pretty much always in time. So here it's telling you that x equals 4. So you got your options. You could use the equation we just created, and then you just put in the 4 for x yourself. You'll get your slightly more specific answer. You can't really have 0.3 of a bass though, so feel free to round that to a whole number. Again, the other option is just to let the table do the hard work for you. Just type it in with your equation that you created and go look at the table for where 4 years have gone by, and you'll get the same general answer. So 3,247, and I'm going to leave it there because you can't really have 0.3 of a fish. So what did I say? I said 30,247 bass. Okay, now the last one's a little bit different. It says, about how long will it be? So we don't know the time. We are not sure how many years are going by before there are more than 4,000 bass. So basically it's kind of the opposite. They're telling us what y value we want. So this is a much better example of, let's just use the table. So I've already got it plugged in. Basically, I don't know this, but I know that I want to have at least 4,000 bass. So up to 6 years, I'm still only at 3,300. So it's getting bigger, getting bigger. Got more bass going. And then finally, when I get to that 15th year, it's finally over. Remember, it said more than. So 14 years, we weren't quite there. We were close. But after the 15th year, we finally jumped over 4,000 bass. So the answer to the question about how long will it take, it'll take about 15 years. Okay, so the goal today is to be able to make equations and then use the table. I'm going to emphasize plugging them into your table. Just let the calculator do the hard work for you. And you might look for where X is something, or you might look for where Y is something. But you're just using that table to make predictions. Okay, so you have to show a filled out notes to the sub for her to give you your worksheet. Your goal should be to finish as much as you can of the worksheet tomorrow at the beginning of class, assuming I come back, which I should. We'll go over any last minute questions you have, and then we'll practice some more. So good luck.